So here we have a chart summarizing what we just discovered. So a proton, symbolized as P+, has a charge of +1, an approximate mass of 1 AMU, and a mass of 1.673 times 10 to the negative 4th grams. So that just tells you approximately how much an AMU really is. It's that many grams. So in other words, not a lot. A neutron has the symbol N0. It has no charge, no electric charge. It has a mass of approximately 1 atomic mass unit, but a neutron's slightly heavier than a proton, so it's 1.675 times 10 to the negative 24 grams is 1 AMU in this case. But to 3 significant figures, these are the same. An electron has the symbol E-. It has a -1 charge. Its mass is actually 1/1840th of an atomic mass unit, but for our purposes, we can consider that to be 0, because it's as you can see, 4 orders of magnitude smaller than a proton or a neutron. So if the atom is going to have a neutral charge, the number of protons have to equal the number of neutrons. Sorry, the number of protons have to equal the number of electrons. If you start adding electrons, you get a negative charge. If you start subtracting protons, you get a positive charge. So let's look at a couple of terms, define a few terms here. So the atomic number is what we call the number of protons. And as we determined before, it determines the identity of an atom. You change the number of protons, you change what kind of element it is. So that's symbolized as Z. If you look at the periodic table, there's the number at the top of the block is the atomic number. And the periodic table is actually organized in order of atomic number. If you read a periodic table left to right, you see it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in order of atomic number. The mass number is the number of protons plus the number of neutrons. Okay, so if I take the number of protons and add it to the number of neutrons, that is my mass number. That's symbolized as A. And this is not the same thing as the atomic mass, which is written in the periodic table block. So the atomic mass is actually an average of all the different mass numbers of the different atoms that exist. So this number is not the mass, it's an average of millions and millions of mass numbers of the atoms. So to find the mass number, you just add the number of protons to the number of neutrons. Isotopes are atoms of the same element, which have the same number of protons, and they have different numbers of neutrons. So if I have a bunch of different atoms, one has a mass of 4 because it has 2 protons and 2 neutrons. The other has a mass of 5 because it has 2 protons and 3 neutrons. These are 2 different isotopes. So they have the same number of protons, but they have different numbers of neutrons. So then, so we have an isotope is the same number of protons, different number of neutrons. An ion is an atom with a non-zero charge. So that means that it has a different number of electrons from protons. So if you change the number of protons, you've changed the element. If you change the number of electrons, you have the same element but a different ion. If you change the number of neutrons, you have the same element but a different isotope. So we have 2 types of ions. An anion, you've gained electrons, it has a negative charge. You can remember that because anion has the letter N in it, which stands for negative. And cations have lost electrons to have a positive charge. That letter T means it's positive. So you can always write your element in this way. So if you have this X, that's the element symbol that you see on the periodic table. Z, the atomic number, goes in the lower left-hand corner, and that's the number of protons. The mass number, so the number of protons plus the number of neutrons in the nucleus, goes on the upper left corner, and the charge goes in the upper right corner. So if I have this symbol here, that is Li, is lithium, and I have 3 protons. That tells me its atomic number is 3. I can read that off the periodic table too. The mass number is 7, which means it has 7 protons plus neutrons. So if I have 3 protons and 7 mass, that means I must have 4 neutrons. And it has a charge of +1, which means it has 1 more proton than electron, so that means it has 2 electrons. So 3 protons because of this, 4 neutrons because 3 plus 4 is 7, which is this number, and then a +1 charge, so that means it has 3 positively charged things and 2 negatively charged things. And if there's no charge written up here, the charge is 0. So let's talk a little bit about how to find the number of protons, neutrons, and electrons, just like we did with the case of lithium. So the number of protons is always equal to Z, the atomic number, the number down here. That's by definition. The number of neutrons is always equal to the mass number, which is the number up here, minus the atomic number. Since mass is protons plus neutrons, you just subtract the 2 to find the number of neutrons. And then the number of electrons is equal to the atomic number minus the charge. So for instance, in this case, I have 3 minus +1 is going to be 2 electrons. If this were a negative number, it would be 3 minus -1, say, and that would be 4, because minus and negative is plus a positive. So this is going to get you the number of protons, neutrons, and electrons in any atom if you know these 3 numbers. So let's look at a couple examples here. Our first example is gallium-69 with a charge of +3. Now if you'll notice, there's actually no atomic number written, but we can easily figure that out from the periodic table. So if you look on the periodic table for the element Ga, you're going to find that it has an atomic number of 31. So that means that it has 31 protons. So now let's figure out the number of neutrons. So my mass number is 69. 69 is the number of protons plus neutrons. So if I take the mass number and subtract the atomic number, 69 minus 31, I should end up with 38. And that's the number of neutrons. So now, let's figure out the number of electrons. So I have 31 protons, and I have a charge of +3, so that means I must have 3 more protons than electrons. So if I take my atomic number, and this always works, and I subtract the charge, 31 minus +3, I'm going to get 28 electrons. So in this case, again, my atomic number is 31. That's my number of protons. My mass number is 69, because that is the number in the upper left-hand corner. And the net charge is +3, because that is the number in the upper right-hand corner. Okay, now let's give this other example. So in this other example, different things are given. So as you can see here, I have 34 protons. Okay, so that means that my atomic number is 34. Okay, now my mass number is the number of protons plus the number of neutrons, which here I have 34 protons and 46 neutrons. So my mass number is 34 plus 46. Which is 80. And then I got to find my number of electrons. So here I have a -2 charge. So I have my number of protons is 34. And then I'm going to subtract my charge again to get my number of electrons. So 34 minus -2 is the same as saying 34 plus +2. So I get 36 electrons. So I have 2 more electrons than protons because this thing has a negative charge. So 36 electrons there. All right. And now let's figure out what element this is. So if I go to my periodic table and look up element 34, I'm going to find that it is selenium. So that last box, I'm not going to go back because it'll erase what I've done before, but our last box there is selenium. 34.